parallel and perpendicular lines. There is a notes page that I've already put on Teams, which you can obviously have a little read through. Just to remind you, parallel lines are the ones that look like the ones in the top right, like train tracks. Perpendicular lines, when you look at them, are lines that meet at a 90-degree angle. So you can see if you were to draw, obviously a much better one than that, but we can see that the lines in the bottom left are 90 degrees to each other, like so. So let's jump straight in. Here's 3 examples of some lines that are parallel. We can see that not all the lines are exactly the same. When we zoom in a little bit, we can see that each of these 3 lines has a different intercept. Notice that the line at the top has an intercept of 4, so it's like the highest one. The middle one has an intercept of 0, and the lowest one has an intercept of -2. So when you're comparing 2 parallel lines, if the intercept is higher, obviously that means it will be above. If the intercept is lower, it will be below. But one thing all of these lines have in common, if we were to draw a little right angle triangle, so let's say, let's do it with a red pen, let's say I went across and up like we've done before. Let's say I'll do that same thing on 3 different lines. So we can draw 3 right angle triangles like this, and we can see that it goes 3 across and 3 up, 3 across and 3 up, 3 across and 3 up. So for all of these lines, rise over step, the gradient is 1. And if we look at the equations, we could see the same thing. It's 1x, 1x, and 1x. So the gradient is the same for all 3. So how do you know if lines are parallel? Parallel, question mark? Well, it's the same gradient. But we can see that the intercept can be anything. It doesn't have to be the same intercept. Higher intercept means the line shifted the same angle, but up. Lower intercept down, but the gradient must be the same for them to be parallel. If the gradients are similar, they may look parallel when you draw them on the graph, but they're not exactly parallel. They have to be exactly the same gradient, and it can be positive or negative. Perpendicular lines are kind of the same thing in that we look at the gradient, but obviously we know that they can't be the same because then they'd be parallel. Again, just very quickly, we can see that the intercepts here are different, which tells us, but obviously it's not going to be a case of above or below because it's going to cross the line. So parts are going to be, so this part here obviously is above, but then there's going to be parts where it's below. So it's not as simple as with our parallel lines. We can say, however, we can again look at the gradients. So if we look at the line A, we can see that the gradient for the first one is 6/3. So the gradient of line A is 2. When we look at the gradient of line B, it's -3/6, which is -1/2. So when we want to compare to check if they're parallel, we first of all look at the gradients, which I've just highlighted in a kind of pinky purple. And what we need to do, if they're perpendicular, then the gradients will add up to multiply to -1. Let's call this one, the first one we say it's like M1, literally the first gradient. Let's call this one M2, the second gradient, A and B. And we say if we take the first one and we multiply it by the second one, it should equal -1. And that's the same for any lines. So when we multiply 2 and -1/2, we can see we get -1. So these 2 are perpendicular. How does that look in questions? Well, you might get a question where you get given a set of lines like this, and it might say, are they parallel or not? Are they perpendicular or not? So again, we'd find all of our gradients. So we can see hopefully that all of the gradients of these lines have a gradient of 1. So M is 1, M is 1, M is 1, and M is 1. When we look at the line E, we can see it goes 2 across, 2 down. So the gradient here is -1. And of course, when we multiply these together, 1 times -1 is -1. So that we have E is perpendicular, but we can see it's perpendicular to all of those lines because they're parallel. So obviously all the parallel lines have the same gradient. So if it's perpendicular to one of them, it's perpendicular to all of them. Finally, we may see one where we're just given the equations. Again, we know that the intercept is less important for parallel and perpendicular than the gradient. So we just look at the gradients for all of these and we compare those. So, for example, we can see which line is parallel to A. Well, A is 6, so obviously D is also 6. So it's going to be D because M is 6 for both of them. I'll put for both. When we look at the second one, which line is parallel to C? Well, C is 2, so of course we need the other line with 2, so it's going to be B, because again, M is 2. It says finally, which line is perpendicular to B and C? So B and C have a gradient of 2. We know that it's going to be 2 times something, has to give us the -1 for them to be perpendicular. So therefore, well, it's going to be 2 times -1/2. It's going to give -1. And then which line has a -1/2? Well, of course, that is E. Because 2 times -1/2 is -1, and you want the -1/2. So that's parallel and perpendicular lines. There's not a lot to it. Just to recap the key things. Parallel have the same gradient, different intercepts. Perpendicular have gradients multiplying -1, different intercepts, and when you're doing it, you'll either get given the lines where you work out the gradients as you've been doing, or you'll get given the equations and you look at the gradients and ignore the intercepts. Have a go at this. This is very common in some of the assessment style questions I've given you, and you may have to use these facts or a combination of these facts, so some questions of both, to answer these.